So now we're going to teach you how to write the equations of a parabola, okay? And sometimes you're going to be given a picture, sometimes you're just going to be given facts about it. But you have to use what you know about your vertex, about your focus, about your directrix, and about the p-value to be able to do this. So we'll kind of go back to this, but basically if the vertex is at 0, 0, you're going to use the information to find p and the direction the parabola opens. You'll plug p into the original equation depending on the parabola you're dealing with. If the vertex is not 0, 0, then you're going to find p in the direction the parabola opens, but you're going to plug it into the more complex equation where you have the y minus k and the x minus h, or the x minus, same thing. Here, if it's at the vertex, you can use the more simpler equation. I wouldn't memorize so much and, just kind of work it out and use your common sense. Common sense is going to really guide you here. So let's think about what this is telling us. This is telling us that we have a vertex at 0, 0. So let's just kind of draw what that might look like. We have a parabola with a vertex at 0, 0. Here's our vertex. Our focus is at 2, 0. Here. Well, that means that it's inside the parabola. So this is a y squared parabola, and a is positive here, correct? Our p-value is 2 units. So we know that p equals 2 because the focus is 2 units to the right of the vertex. And so we know the equation that goes with this is 4px. Y squared equals 4px because, again, our vertex is 0, 0. And so all you need to do here is plug in p, which is 2. And so you get y squared equals 8x, and that's the equation for this parabola. That's all you need to do. So again, you come to number 2, and I think it's important to sketch a little bit and just kind of have a sense of what you're doing. Notice here our vertex is again at 0, 0, and our focus is at 0 and 3/8. So let's say this is 3/8. Well, that tells you then if the focus is here, okay, that means that this is a parabola that opens upward, which means it's an x squared. So again, x squared equals 4p times y. Now, if this focus is at 0 and 3/8, then I know that p equals 3/8 because that's 3/8 unit above 0. And so my equation is going to be x squared equals 4 times 3/8 y. And when I do the math, I get 3/2 y. And so this is the equation of this parabola. Now, once you get to here, you can leave it in this form, and we're totally okay with that. Or I know you probably want to see the x squared and the y on the other side. So if I multiply both sides by 2/3, I could get 2/3 x squared equals y, or y equals 2/3 x squared, which is more traditional. Either one of these is acceptable. However, this is the first form it's going to come in, and I'm totally fine with that, so I would stick with that. But on a standardized test, just know that this equals that, which equals that, in case it's a multiple choice question and it comes in a different format. So again, let's keep going. Here's another one. Vertex at 0, 0. So let's keep doing our little sketch so you can kind of see and visualize. Here's my vertex. My focus is at 2/3 0. So let's say this is 1, right? So 2/3 0 is right here. So that means my parabola opens this way, right? So I know this is a y squared equals 4px, and I know that p has to be 2/3 then, because I'm 2/3 units away from the vertex. So it's going to be y squared equals 4 times 2/3 x. So y squared equals 8/3 x. And there's my equation. Okay. Now, this one tells to me a little bit different, right? This one says here, on the vertical axis, the vertex is 0, 0. And it passes through -2, 12. So they're telling me here's -2, and let's say here's 12. They're telling me it passes through here. Now, the on the vertical axis is important because what it's telling me is the axis of symmetry is the vertical line. And so what it says is that this graph is looking like this. And so that's the axis of symmetry. That's basically what this is telling me. Okay, so what happens is now I know that this is going to be an x squared equals a 4px. And so I'm going to have to try to figure out what the p is. So I don't really know what the p is, but I do have an x and a y value that I can plug in. I could plug x in for the x there, and I could, 4py, sorry. And I can plug the y value that they gave me here, and I can do the math. So 4 equals 48p, and if I divide both sides by 48, I'm able to identify that p is 1/12. So now that I know that p is 1/12, I can go back to the original equation and I can plug it in. So x squared equals 4 times 1/12 y, and x squared equals 1/3 y. And that's the equation of this parabola. In the end, the equation has to have the variable x in it and the variable y in it. The variable that goes away is the p part of it, okay? All right, so now we have a little bit different because, again, this isn't located at the vertex of 0, 0, right? So remember here, you know that your vertex, remember your vertex is always hk. And so here, my h equals 1 and my k equals 3. So again, let's kind of draw that out, right? I've got 1, 1, 2, 3 here. And my focus is located at -1, +3. This is my focus and this is my vertex. So I know that my graph must look like this. So this is a y squared graph, right? So this is going to be my y minus k squared equals, and it's going to be 4p times x minus h. Now, again, my focus is located there. I can count and I can figure out how many units away it is. And I can see that my focus is 2 units to the left of that vertex. So I know that my p equals, let me kind of move this over, but I know that my p equals 2 units. Okay? So again, now my equation is going to be then, I'm going to plug in my k, y minus 3 squared equals 4 times 2 times x minus h, which is 1. Now, the only problem here is when I do this, notice that I get y minus 3 squared equals 8 times x minus 1. And if you notice that this value here is positive, which would indicate that the graph would open in the other direction. Because we know the graph opens to the left, we know this 8 there has to be a -8. And so here is where this is, I'm just going to insert the negative because I know since my graph is opening to the left, that value has to be negative. And this is the equation of that parabola. So that's the only tricky part that you have to do here when it comes to graphs that open in an opposite direction, than the norm, in the negative direction. All the previous examples we did, the a was positive, so we didn't have to account for that. Okay, so again here we have a vertex of 0, 0 and a directrix of y equals 1. So once again, I'm going to sketch this. My vertex is at 0, 0, so that makes it kind of easy, but my directrix is the line of y equals 1, which means my directrix is going to be this. Let me do it in a different color. My directrix is going to be the line here of y equals 1. And so I know that this directrix is 1 unit above my vertex, right? So I know that my graph is going to open down like that. I know that it is an x squared graph, and I know that my focus is going to be here inside, right? Again, what do I need to do here is the equation. So what I'm going to do, I know that it's going to be an x squared graph, 4py. I know that p is 1, so x squared equals 4 times 1y, so x squared equals 4y. And because it opens down, right, it opens down, I know that that 4 there has to be negative. And so that's the equation of the line. And again, I have that negative part there, which makes me have to take it into account at the end there. All right, a couple more. So again, here's another vertex at 0, 0. I'm going to just kind of draw it out. Vertex at 0, 0, and the directrix is the line of x equals 4. So that means my directrix is a line that goes down like this. So I know that this is a parabola that opens this way, and that my focus would be over here, right? But again, they're not asking me for the focus. All they want is the equation of the line. So I know that a line that goes to the left like that is going to be a y squared line, so I'm going to start with that. I know that my p-value is 4 because it's 4 units this way. So it's going to be y squared equals 4 times x. So y squared equals 16x. And because it opens to the left, I know this is a negative 16. So y squared equals negative 16x. And again, we're going to work on a few more practice problems just to keep kind of giving you exposure to this. Again, it says that it's on the vertical axis. The vertex is at 0, 0. So I know my vertex is here. It passes through point -2, -2. So it passes through here. So I know that my graph is going to look like this and like this. This vertical axis lets me know that my axis of symmetry is here. So I know this is going to be an x squared graph because it opens up down, right? So x squared equals 4py. Now it tells me a point it passes through, so I'm going to have to plug in those points to try to figure out what my p-value is. So I'm going to plug -2 in for x and a -2 in for y. I'm going to get 4 equals -8p. When I divide by -8, I'm going to get p equals -1/2. So I got that. And then I'm going to come back to the original equation. X squared equals 4 times -1/2 y. X squared equals -2y. Like that. Let me fix that. -2y. And that's good. Notice that the a value is negative, and that's exactly what I need because, again, it opens down. So I know it has to end up being a negative, and that's good. There's my equation. All right, a few more. Now we get back to these. This one here has a vertex at 3, 2. So let's kind of look at this one again. Let's see what we need to do here. So again, my vertex is at 3, 2. My focus is at 1, 2, so my focus is here. So I know this is a graph that opens to the left, like that. My p-value is pretty easy there to recognize. If I started at 3 and I went to here, it's 2 units to the left, so I know my p-value is 2. And I'm able to, this is my h and this is my k, and I know that since the graph goes left and right, it's a y squared graph, so it's going to be y minus k equals, or y minus k squared equals 4p times x minus h. So I'm going to have here y minus 2 squared equals 4 times 2 times x minus 3. So y minus 2 squared equals 8x minus 3. Now, because we noticed that the graph opens to the left, right, we know that this has to be then a minus 8x minus 3. So remember, you always have to kind of think about the fact of which direction does it open. If it opens to the left or if it opens down, this number here is going to have a negative associated with it. And this is how you can leave it. And that's the equation of that parabola. And last one, we have over here a focus of 0, 0 and a directrix of y equals 4. So again, let's think about that. My focus is here and y equals 4, 2, 3, 4. This is my directrix. right? And I know that my vertex lies in between these two. So I know my vertex has to be here at 0, 2. And my p-value, right, has to be 2 units. Because again, p is the distance from the vertex to the end. Or remember, it's also the midpoint between the focus and the directrix. If there's 4 units between them, the midpoint is at 2. So again, that's how I can figure it out. And then again, if my focus and directrix are there, then I know it's an x squared graph where a is negative. So again, I'm ready to do my work here. Remember, it's x minus h squared equals 4p times y minus k. And I know here I've got x is 0, so it's just x squared. So x squared equals 4 times 2, and this is y minus 2. So x squared equals 8 times y minus 2. And there's the equation of my parabola. And that's all you need to do. Now again, let me think about that. Notice that my 8 here is positive, and it can't be, right? My 8 has to be negative because it opens down. So I do have to take into account here and make that negative. And that's the final answer.